In this lecture, we're going to look at the percent concept. So we know that percentages are expressed as part over whole. And we could say, for example, we could just use a pizza, for example. If somebody ate 5 pieces of pizza and there were 8 pieces total, we could say 5 divided by 8, and then times it by 100, and say that they ate 62.5% of the pizza. So we're taking part over whole. Now, just like our other conversion factors, we can take this and we can use the reciprocal of it for analysis. And I'll show you an example in a minute. This example is talking about bronze and how it's an alloy of copper and tin mixed together. So it's a mixture of 2 solids to make bronze. So if a sample of bronze contains 79.2 grams of copper, which is Cu, and 10.8 grams of tin, which is Sn, what is the percent of copper in bronze? So let's find the percent of copper and let's find the percent of tin. So we've got 10.8 grams of tin. So to find copper, we're going to do the part of copper, 79.2 grams of copper. So that's the part over the whole. And the whole would be 79.2 grams plus 10.8 grams. That would be my whole. And then, I need to times it by 100%. And to find the percentage of tin, I would need to take 10.8 grams of tin over the whole, which is the same 79.2 grams plus 10.8 grams, and times that by 100. So plug that into your calculator. And for copper, we should get 88.0% because we want 3 significant figures. And for tin, we should get 12.0%, again with significant figures. So we could also look at both of these numbers, and if we added them up together, notice that we would get 100% for the both of them. So a percent can then be expressed as parts per 100. So if I said I ate 25% of this pizza, I could also say, well, I ate 25 out of 100 parts of that pizza. And then we know that this could be reduced down to 1/4, right? 10% can be written as 10 over 100. And we know that this can be reduced, but we can take percents and write them as parts over 100. So if I was told that a rock was 4.70% iron, Fe, I could also say that a rock had 4.70 grams of iron for 100 grams of the whole rock sample. So we could write it like that. I could also write it that for every 100 grams of the rock sample, 4.70 grams of that was iron. So these are just reciprocals of each other like we've been talking about the last couple of lectures. So in this example problem, it says the Earth and the Moon have a similar composition. Each contain 4.770% iron. So we're going to go back and we're going to write our 4.70 grams of iron over 100 grams of rock. Or, remember, we could write it as 100 grams of rock for every 4.70 grams of iron. What is the mass of iron in the lunar sample that weighs 92 grams? So I'm given that I have 92 grams of rock. I want to know the mass of iron. It even says, what is the mass of iron? So I need to do some sort of equation where I get grams of Fe for my final answer. So I need to use the conversion factor that gets rid of grams of rock down here. So what do I want? I want grams of Fe, right? It's what I want over what I've got. I want grams of Fe, I've got grams of rock. So which one of these conversion factors is it? This guy. We're going to plug that in over here. So I'm going to say my 4.70 grams of Fe over 100 grams of rock. And I should get 4.324. Now we do need to be careful of significant figures. I have 2 sig figs here for my 92 grams. I have 3 sig figs for my 4.70%. So I am limited to my 2 sig figs. So I need to say 4.3 grams of iron and circle that final answer.